Week 3, Lesson 2. This is a really, really short lesson. There's only actually the one example, and it will seem very, very similar to the last example. Just so you guys know, I'm actually making this video on October 6th. So I'm kind of ahead of schedule. But when you're in class, or for those of you that are in class, if you're not doing distance learning, or those of you that are on Zoom, please remind me during this particular week to show you like a three-dimensional model of this particular concept. It's really kind of hard to understand without, as far as visualizing it, for those of you that are visual learners. All right, but as far as the computation, it's easy. All right, so again, question says, find the angle between two planes. Okay, and if you remember, we just found the angle between two lines. All right, so what we're gonna do is, instead of trying to do the planes, we're gonna find the angle between the normals. All right, just remember that a normal is perpendicular to the plane. All right, and then something else to notice, kind of cool here, these represent planes. All right, so it's not something you have to do. It's not a computation or anything. It's just sort of notation. It's saying, hey, here's a plane and here's a different plane. All right, so the normal for plane 1 is 1, 2, negative 2. And the normal for plane 2 is 2, negative 3, negative 6. And literally, you're just going to use the exact same formula that you did on the last lesson and figure out the angle between the two planes. All right, so the dot product is going to be 2 minus 6 plus 12 equal to the square root of, let's see, A is going to be 1 plus 4 plus 4. Magnitude of B is 4 plus 9 plus 36 times the cosine of theta. Solving for the cosine of theta and simplifying a little bit, you get 8 over 21. If you put that second cosine into your calculator, you will get an angle of 1.18. That is rounded to 3 significant figures, and it is acute.